Alright, so today we're going to be talking about just vectors and vectors in general, just to get a feel for really what they are and what they mean. So I'm going to look first at a 2D example of vector. I have two dimensions right here. So here is my y-axis and my x-axis. And let's make a vector, any vector. We'll do 3, 2. And generally when we write vectors like this, we have two components to the vector. And the first one usually is denoted I hat. And I hat is 1 unit in the x direction. Then we have the next, after the comma, we have our next component to the vector, and that is usually denoted j hat. And that is just 1 unit in the y direction. You may actually see these I hats and j hats sometimes as x hat and y hat, which, to me makes more sense, but most people use these. We also, in 3 dimension, we have another one, and that's the z component. That's usually denoted by k hat. So now that we went over these unit vectors, what do these unit vectors mean? Well, in this case, we see that we have 3 I hat and 2 j hat. Well, that really means 3, well, this is just a 3, a scalar, times I hat, which gives it 3 units in the I hat direction. Then comma, or actually not comma, excuse me, but plus 2 units in the j hat direction. And we see that these are different, right? These is giving me 3 in the x direction and 2 in the j hat direction. So we cannot add these. But let's draw them and see what this vector gives us. Well, we know if this was a point, for example, we could write a point like this, 3, 2. That would just be, well, we'd move 3 on the x-axis. It'd be 1, then it'd be 2, it'd be 3, be here, and then it'd be 1, 2, and then, so it'd be a point here. Well, a vector has much more information than a point. Now, I'm going to write this vector in red. And we'll call this vector, let's call it r hat. R arrow. And the arrow denotes a vector that's not a unit vector. So, I wanted to draw this. Well, it would be 3 units this way and 2 units up. And this would be just a line that goes to that point. See that would be the vector, and that's really all it is, and this is vector r. So it has a lot more information than a point. So what if we wanted to find the magnitude of this r hat vector? And the magnitude of r vector in this case, well, let's think about it. It would just be this line, right? How can we find that? Well, let's look at this. I'm just gonna encourage you to pause it and think about it and try it, but we have a right triangle here, and we have this angle here. We'll call this theta. Well, we can find, right, this magnitude by finding the length of this. And we know that this is 2, and that this is 3. So this is going to be equal to the square root of what? Well, we know that a squared plus b squared equals c squared. And we see that c squared must be, well, this squared. If we want to find this magnitude, which is this length of r, we'd have to square root that, just like the Pythagorean theorem. So, in this case, we'd have 2 squared, and we'd have plus 3 squared. And that would just be the length of this as you go from here to here. And that would be, let's see, 4 square root 4 plus 9, which is equal to square root 13. And that is a scalar. We notice that we lose the vector components. It's just a length. It's just a certain amount, right? See how long it is. It's not broken up into components. So now we see, right, that we have the magnitude. Now what if we have this magnitude now, right, which is square root 13. How can we relate it? Because how can we take this and go back here? Well, we know that we have this angle theta. So if we took cosine of theta, so if we had cosine of theta, right, we know that equals adjacent, which is 3, over the length of this, which is just square root, or the magnitude of r. So we could find either this angle. So we could find this angle simply by, which is the adjacent to this angle, and then r, we solved r's square root 13, which is just going to be equal to theta is equal to 3 over square root 13. So anyways, I think we did enough two-dimensional vector analysis. Let's do some three-dimensional. That's really where it gets fun, right? Because the world we live in is 3 dimensions, right? So let's get this new vector. Let's give us a new vector. Should we make this new vector? Let's call this vector. Let's call this a vector v. And we'll make this vector components have, to make it interesting, let's do 3 on the I hat direction. We'll do 1 in the j hat direction. And we'll do, let's do 1.5 in the k hat direction. So let's also write this vector by listing its components individually so we can see, other ways to write it really and get a feel for it. So we'll do 3 I hat plus, well, that's just 1 times j hat. So that's just j hat. And then we have plus 1.5 k hat. So let's try to write this on our axes. So we have the y component is in this way. So this is going to be j hat. And then this is going to be I hat. Okay, so we're going to do 3 in the x direction. So it's going to be, well, 1 times this, 2 times this, and then 3 times this. So this should be 3 I hat. She's going to remove that unit vector over here. Oops. And we have 1 j hat, so it's going to be equal to the unit vector in this direction. And then 1.5, so it's going to be about this length, and then half that length of the k hat. So let's try to draw this vector in 3 dimensions. And this is where it really gets interesting and fun. So we see that it's going to be, if we take its projection of where it really is going to be, which is this much high, it's going to be like something coming out like this, but this high. So let's draw this like that. And then we want the vector to come towards us like this. And that's really hard to see. So, but let me change the color, maybe that'll help. So if we it's gonna really come towards us, right? Like that. Okay. So let's do one more example, I think would be good of drawing vectors. And let's do this one where it's not, where we really can see the vector. So let us do vector with components. We'll call this v2. I hat will be 1. J hat, we'll make j hat 3. And k hat will be, let's do it 3 again. And I forgot to label my axes. This will be the x. This will be the y. And this will be the z. So we're going to go 1 in the I hat direction, which is right here. 3 in the j hat direction. It's going to be pretty long. And then 3 in the k hat direction, which is right here. So we're going to draw boop, 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 boop. And then boop, 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 boop. That's really bad. So we're going to get a vector that comes like that. And its projection is going to be this angle here. You can see that, but that would be its projection. This would be a right angle. So that is an introduction to vectors and them in 2 dimensions and 3 dimensions.